Hi everyone, LCC 150D, Statistics for Informed Decision Making. This week we're looking at Chapter 11, which deals with sampling distributions. I'm going to condense this chapter and then I'm going to veer you to a few problems that I will solve in another format. So make sure you go back to Blackboard on this sheet and you can see on this chapter, and you can see where to go to solve the problems that I assigned to you, which are specifically number 26, 31, 35, and 36. But first, let's talk about the terminology here. The parameter, I mentioned this before. A parameter is an unknown number that describes a population. Okay, so think of population as everybody. And the number that you find about the population, that data is called a parameter. Now, when we take a sample of the population, we find a statistic. So it's very rare that we can find the whole population and find a parameter. But most of the time we take a small sample of that, and then the numbers that we get are statistics. So we've talked a little bit about this before. So there's going to be some variability when you take a sample size as compared to the parameter. And that variability depends on the number of people or the number of samples that you have. Okay? So those are the things we'll be talking about. Let me just first go to this site. This is the Census Bureau. It's a report of 2010. They had the census last year. So reports are coming out. And the report last week I mentioned in the announcement this week was about the population. We have 308 million people in this country. Okay, and you can see the chart here is how much it's changed and so on, as the number of people in percentage. And why do we do a census? It's because we have to do the congressional districts by redistricting the data. So in other words, we have 2 representatives in the House of Congress, House of Representatives. That's determined by our population. We have 2 districts in Maine. For instance, if you go to Texas or whatever, I don't have the numbers in front. Let me see. Texas, that's the total population. They don't give me the number there, but you can find the number of representatives. I was just reading this morning where North Carolina will lose a representative because many of their people are out of the state in the war, especially in the areas where they have bases, army, military bases. Most of the people have gone on to other countries, and so they've lost some population. Therefore, they will lose a member of the House of Representatives. And what that means is that they have less of a voice in Congress and less power. When we in Maine used to have 3 representatives a long time ago, way before my time, yes, people were alive in those days, the Maine had a little bit more power. Of course, every state has 2 senators, but representatives are determined by population. So that's why we have a Census Bureau. So the numbers that come out when we have this census, it's 308 million people here, almost 309, that's the population. So all of these numbers, all of these data that are coming out, that's all parameters. Okay, so if you did a sample and wanted to see how a sample in terms of population, like we have in white alone, 72.4, that's up of 5.7, blacks 12.8, it's up 12.3, and you can see the Asian population has grown 43.3% in the last 10 years. So that's something that if you did a small sample in a classroom or in an area, and you could see if you distributed by simple random sampling, that has to be random, your numbers should come out close to this according to the theory of statistics, which is what this chapter is all about. So here we go. This is just what I was saying. If you chose a sample of 1,600 people and asked if they regularly watch a certain television programming, and 24% said yes, the parameter of interest here is that the true proportion will be close to the statistic of 24%. Now, when you watch a television show, there's a sample. You're part of a sample. Now, how do they know the day after a television show, such as American Idol, that 24 million people watched it? Well, they are people as part of a sample who are Nielsen ratings people. Some of you may have filled out a book a long time ago. Some people have a box on their TV that tells them tells these Nielsen people what they're watching. And the data that they gather is the statistic. And because it's simple and random and it's a sample, the numbers that they get can truly predict what the population then the population watches. So when American Idol on Fox TV is watched by 24 million, and that's the top-rated show, Fox, the company Fox, can charge a lot more for its commercials. And the same thing goes for such shows as Super Bowls and the Oscars. When a show is not watched by a lot, of course, they can't charge as much, and that's why they usually cut it. So when we look at a parameter, the mean of the parameter is written and denoted by this letter mu. We talked about that before, okay? And the mean of a sample, the sample you take, is x bar, okay? That's x bar. That's a standard English letter, x. This is the Greek letter mu, okay? That's a statistic. And we take a sample to estimate the mean, the population mean. The true proportion of a population is p, and the proportion of a sample size is p hat. We're not going to look at that too much in this chapter, so don't worry about that. Here's an important statement, and it should make sense to you, as you probably have known this in your heart and soul for a long time. Consider sampling at random, always important. Random sampling, very important, from a population with true mean mu. Okay, that's the population. That's what it actually is. You do a sample. As the number of independent observations of sample increases, the mean of the sample gets closer and closer to the true mean of the population. So if you were to take a sample and you wanted to estimate what it is to the whole population of the United States, well, we have 308 million people. So if you took 25 people, it probably wouldn't be a very good estimation of the x bar as it gets close to mu. But you can increase that probability that it'll be close if you add a lot more people. And the sampling distribution of a statistic is the distribution of values taken by a statistic in all possible samples of the same size, n. N is the size of your population. If I just said 25 people, that would be n. Okay, and you need to describe the distribution by the shape, center, and spread. Think the normal curve. Okay, so mean and standard deviation of sample means. This is a little bit different here. So if numerous samples of size n are taken from a population mean mu, you take a lot of samples of size n, and this are the parameters here, mu and standard deviation sigma, then the mean of the sampling distribution x bar is mu. Okay, if you take a lot of people, the population mean and the standard deviation is the sigma divided by the square root of n, and that's the standard deviation for the sample. So in other words, if you do a simple random sampling and you find a mean, that's x bar, they say through this law, and it's beyond us in this course, we don't take this course for the theory of stats, they say that if you do that, then your answer that you get in your stats is, you can properly say with confidence that it's the same as the population, which is kind of cool. In a standard deviation of it is all you have to do is take the standard deviation sigma here, which you would know, and divide by the square root of the number of people that you have. And that's what we're going to be doing in the problems. Okay, so since the mean of x bar is mu, we just said that, we say that x bar is an unbiased estimator of mu. So again, if you took a sample, you found the mean, you can say that the mean of your sample is the same as the mean of the population. If you took a mean of your sample, x bar, you can say it's mu. It's an unbiased estimator. Now, individual observations have standard deviation, individual observations have standard deviation sigma, but sample means are x bar. Okay, of the means x bar from sample size n have standard deviation, and it just said that. So in other words, the standard deviation of a population is sigma. When you want to find the standard deviation of your sample, you do this. Sigma divided by the square root of n. If you had 25 people, square root of 25 is 5. You divide the sigma by 5. That's your sample standard deviation. So it's not the same. The means are the same between sample and population, but the standard deviations are different, and this is what makes it different. So the averages are less variable than individual observations. Okay, so you want to make it, you really don't want variability here. You want it to be close to what it actually is if you took a sample of it. So the way you write this is if individual observations have a normal curve, this is n, remember n, this is the population here, mu, average, your mean, and then sigma, standard deviation. And the sample mean, it's going to be written this way. Normal curve, mu, remember we just said they're the same. Your average of your sample is going to be, your mean of your sample is the same as the mean of the population. And then you do this little operation here, you take the standard deviation and divide by the square root of n. That will give you your standard deviation for your sample. Okay, this is if it follows a normal distribution. And here's the line from the book. If measurements in the population follow a normal distribution, then so does the sample mean. So if it's normal for the population, it's normal for the sample as well. Then the central limit theorem here is if the random sample size of n, and 25 people, 30, 40, 50, 100 if you have a lot of time, from any population mean mu, okay, the mean is mu, that's the population mean, and standard deviation sigma, that's all population, think big. Then when n is large, okay, the more people you investigate or take the data of, the sampling distribution of the sample mean x bar is approximately normal. And we just did this. So the central limit theorem is really putting words to this previous slide. So x bar is approximately this. Okay? That's no matter what distribution the population values follow, the sample mean will follow a normal distribution if it's size. So even if your population distribution doesn't look like normal, when you take a sample, you get a normal distribution. Again, where does this come from? It comes from theories and laws of statistics that is beyond our course. If you majored in math, you would have taken a statistics course, you would have found this and proven it. Okay, so how large must n be for this to be true, for this thing to be true here, this normal thing? Well, here we go. The CLT stands for central limit theorem to hold. How large must n depends on how far the population is from normal. Okay, the further from normal, maybe it's all messed up, it's not even normal, the larger the sample size needs. So you have to take a lot of people to make it normal. So a sample size of 25 or 30 is typically large enough for any population distribution encountered in practice. So 25, 30 is not bad. And if the population is normal, any sample size will work. Okay, so again, if your population is not normal, then you have to take a lot of people. Let's say, remember the height of people, men or women. If you did, and you know it, you know what the population mean is and the population standard deviation. Now go into the mall and take 25 to 30 people at random. Because that population is normal, your statistics should be normal as well. And that's the part of the law that's going to be proven or supported. So you could think that you took 25, 30 people at random at the mall, you measured their heights, and then you found the sample mean, which would be the same as the population mean, and then your standard deviation would be the standard deviation of men's height, for instance, and divided by the square root of either 25 or 30 or whatever number you got. So this is basically what is important in this chapter. It can be kind of heady, and I just want you to take your time. Now, attached to this, and under the websites and Blackboard, I will add, it's called a pencast, and LiveScribe pencast, and it will tell you how to solve the problems that I asked you to do. Take care.